What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Hi everyone, welcome to Charlotte IoT, and this is a special meeting for a number of reasons, but one of the really cool things is we just passed over 1,000 people. So this group is like kicking butt. You're doing really good. We should do something to celebrate. I wanted to do something IoT-ish to explode or something, but didn't get around to it this time. Maybe the next meeting will make something explode. So our group is all about learning, and we do technical presentations, we do hands-on hack events like today, and so like our core mission is cool people getting together to learn, and it's for everybody. It's for the wizards, it's for the novices, and what's really nice about this group is there are a lot of senior people who like to help out the more junior people. And so if you guys know junior people who want to come, encourage them to come, and everyone will help out, and it's a really good community here. And the reason this group is like amazing is this board is just like totally amazing, and I just am so grateful for this board. When I get like overwhelmed and bogged down, people like Mike fill in, and he got the Azure meeting scheduled and we've got it coming up next Monday. We have an Azure boot camp, and I've got a slide on that. But thanks for getting that up and done, and because like things happen at the that we need to proceed on, and in this group, just everyone in this is leaders, and they take charge and do things. Graham's our facilities person, and he's the reason that we're here in this great building, and he orders the food. And Rob's our hands-on lab coordinator who does most of the content for our labs and just does amazing hands-on labs. Joseph is doing the streaming, and he's the one in charge of doing this right now. And he's also like a go-to guy for getting everything done. Mike is our Hackster ambassador, and he's also our swag coordinator. And like we have amazing swag, and thanks for getting all that done. And Christoph is new, and he's going to be helping with like big events, like we just did the one at the Speedway. And Glenn is doing our social media, so he's the reason that now all of a sudden you see us on Instagram, and we're all over the place. And it's probably like one of the reasons why our membership just pushed over 1,000 people, because our acceleration just picked up. Last month, we got more people than usual who joined, so that's really sweet. And Ratish, are you here? He's just joined the group, and we're not sure exactly what he's going to do, but I'm sure he's going to do something epic. And we never know what people are going to do when they join. We just like people to join, and they tell us what they're good at, and we like make new positions. We have a YouTube channel, and this is streamed on YouTube, and what's really awesome about that is you can watch this over and over and over again. If you have a question on something, then you can get it out and watch it. But if you can't make the meeting, it's really not a big deal. People like Mike will travel from Raleigh, and he'll never miss a meeting. But this YouTube channel is great. It's Charlotte IoT. It's our special URL on YouTube, so that's nice. And we also do other social media. Our Slack channel is really active, especially for the hackathons that we're doing to help paraplegics. And Jeremy's going to talk in just a second on that. But we also have Charlotte IoT. You can follow that. When you join our meetup group, in the profile section right after it, it asks you questions for your email address and your Twitter. I know you can enter it on your profile, but if you don't do it in the second place, Meetup doesn't actually give us your info. and so we don't know it. But if you give it to us there, then if we ever need to contact you for a hackathon, or if you do something really awesome in a meeting and we want to tweet you, then that's how we do that. Oh, and also it's how we do Slack invites. So Mike looks at that at least monthly, and he does a download, and he imports the names into Slack and sends out invites to Slack. It's the only way to get on Slack. That, or you have to message one of the board members. We've got some really awesome sponsors. One sponsor is my company. I'll talk about that in just a second. Hackster is like completely amazing. They give us like amazing swag, and they're the reason why we're doing a special meeting on Monday. And just every month they like surprise us with new toys and fun things. And we've had so many hackathons this year, and a lot of the reason is because Hackster's been just amazing. Graham, can you talk about how awesome Snap is?
Yeah, sure. How many first timers? I was, I guess, going to see. Okay, cool. So, Snap AV, we are a manufacturer of audio video equipment. We make about 3,000 different products in the AV space. And about 4 years ago now, we started building an IoT platform called Oversheet. And we're now managing about 600,000 devices in our cloud that allows the AV professional to remotely configure and manage all that. So when I met Dan, I said, hey, this is a great thing that you're doing, let's have it at our place because we got this great room. And so we've had it here for now, 2.5 years or so?
Yeah, it's been awesome.
So yeah, but welcome.
And here's a picture on Hackster. Please, during this meeting, send out a tweet and copy both Hackster and Charlotte IoT. And they're always good to tweet a thank you. They also give us $200 a month that we use for swag, and we buy things for our hackathons, like for the for paraplegics and for other things. And a little like commercial about my company. My name is Dan. I'm one of the co-founders of Logical Advantage. We've been in business 14 years. We do epic projects, enterprise projects. We like to do the hard projects. And we just did a pilot and a manufacturer for IoT where we have sensors on, they're going to have over 3,000 of these spindles right now. It's only on 24 of them. But we're collecting data for operational efficiency so they can make decisions on do they want to do automatic change orders and labor costs. It's all with cheap microcontrollers. We're like the barbarians at the gate, cheap microcontrollers and version control that we're better than the competition. And we did a smart city project this is over 10 years ago. The first city was Toronto. We put RFID tags on trash bins. First city had over 1 million, and now it's in 130 cities, and it's tracking millions of these carts all throughout the cities. And so we know who's recycling, what address, and do billing or set up games for cities too. We do all kinds of really cool projects. One cool one is this shirt. So if you tweet Logical Dan or Logical ADV, my company, the shirt lights up. And Jeremy, can you come please and talk about how awesome our hackathon was, and will be?
Sure. So we've been working with a couple different quadriplegics. Sean is local, and Nick is not, but we've been working really closely with both their caretakers and the facilities that they're in. We're going to be going out and visiting them and looking at some things that you never think of when you're looking at IoT. And it's like, for example, one uses Echo for voice control. Well, it requires Wi-Fi, and we're going to have Wi-Fi at certain places. Also get to do some fun stuff with Azure and with the Amazon Echoes as well. The whole idea, though, is to make life easier for the quadriplegics and for the caretakers. Imagine having to, turn on a fan just to get a little cooler, and having to call somebody to get that done, or having to turn off a light. Just very simple things that we take for advantage. These people, we can give them that freedom through IoT, and it's just an amazing thing that we're doing. We're looking to do another hackathon maybe July 15th, And Mark's not here. Mark has been awesome in helping with me while Dan's been on hiatus and giving him a little time off. But I'm going to be reaching out to a couple of people who are at the hackathon to gather code and stuff that wasn't gathered and kind of figure out where we are. And then on the 15th, we plan on coming in and doing a full bore another hackathon, and hopefully we'll have a lot more ideas, a lot more information, and we'll be able to get a lot of good work done. So if anyone's interested, just, we'll have something up on the page.
Sure. We'll add a meetup site to register.
Yep. And then if you got any questions or something, just reach out to me or Mark, and we'll help out however we can.
Yeah, so talk to Jeremy if you want to help out. You don't have to wait for the hackathon, because we have these projects on GitHub, and you can post code and update code. Everything's open source, so our code's open source. We got a Hackster site. We're going to be publishing like all the information on how people can copy and replicate this and make it like better for all the other cities and groups that are going to do similar things. We're trying to like inspire others to take what we start with and make it even better.
Right. And there's actually a big community kind of around this already, and so hopefully our stuff can start bringing it into that community, so that open source projects like these can really help people that need it.
And Hackster's been really good with connecting us with people who can help like pay for some of this stuff. Particle is really stoked. They're featuring us on their website sometime in the next month or so. The Particle for Good will have us, and they've offered to give us like 100 particles if we want it, photons. And so if you guys have contacts with people who can like help donate things, then please help us in that way too, because we're always looking for different ways to make this better. So our next meeting is Monday, and that's not a lot of time. And this is Mike filled in for me when I was we had a funeral and whatnot. And he got this on the website, and thanks for taking care of that. But this is a really great opportunity for our group. And Hackster picked us as being like one of the leaders in IoT for their groups. And the goal is for us to have like 100 people for this hackathon. And so we need to, since we don't have much time between now and then, tell all of our friends that this is going to be epic and get them to come. But it's an Azure IoT Bootcamp. And it'll be like projects like this. I didn't mention that this project we're using Azure IoT Hub to ingest all the data from all the different spindles. And this is on the Azure IoT suite. And it's going to be epic. There's going to be 3 30-minute labs. And so, and someone from Microsoft is coming in. Do you know where they're coming from? Who knows? Maybe Redmond or...
There's going to be a call on Friday.
No,
So
okay.
they're probably coming out from Redmond, and I think they were trying to make it a tour. So what they were trying to do is line up the different Hackster groups in cities
I see.
on the northeast to start with. And I think we're the first.
Yeah, save the best for the first or whatever.
Well, so it's a little chaotic.
Yeah, awesome.
And the organization hasn't been as crisp as I might expect it to be with Microsoft.
Yeah, well, thanks for getting that on our site, and I think everyone should tell their friends about it, and it'll be another like Charlotte IoT Epic event.
And Dan, we're hosting it here, right?
Yeah, it's hosted here. Yep.
So,
Yep. The following month, we normally meet the first Tuesday of the month, but it's on the 4th of July, so we're going to push it back to the 11th of July. And it's Lewiston, and they're going to like do a hackathon on ESP 8266, and so I think that's going to be for everyone who's doing home automation and things like that. It's going to be a really good workshop. And finally, Mark Easley, where did you travel from?
Just Raleigh.
From Raleigh, that's awesome. Came from Raleigh, he's with Texas Instruments, and Texas Instruments is like one of the leaders in silicone and IoT, and we've tried to find someone from Texas Instruments for a while, we couldn't. And so it was awesome when Charles Lord hooked us up with you, and you were like really eager to do a talk, and so we're really stoked to have you here. And like Texas Instruments has some really sweet IoT products, and the CC3200 and others. We're going to do this on the 3100, or
That's right, yep.
so yeah, this will be great.
All right.
Awesome. Cool. Thank you, Dan. So I'm Mark Easley from the Texas Instruments University program, actually. So I represent actually the whole East Coast. Pretty cool job. Work with a lot of students most of the time, but happy to do these types of outreach events for our regular developer community as well. And just before we start the workshop, just want to make sure you guys are all level set here. We are going to be using the Hackster.io website for our lab materials today. So make sure you go to this URL, goo.gl/V BYMU case sensitive. So make sure you're capitalizing that V and W on the bookends. What's our Wi-Fi situation here, Dan? Is it
Tsunami? Grant, who knows the password?
Tsunami WPA?
I'm going to give away the secret to everybody.
Oh yeah.
Oh yeah. Okay. Well, anyway, for the folks in the room, it's Tsunami WPA, and then we'll get the passwords out later.
It's okay. It's
Uh-oh.
value added in the number 1. So VALUEABDD and the number 1. Is that-
Value added one,
There you go.
and it's Tsunami WPA. Cool. All right, so you can hook up to that. We'll see if our launch pads will hopefully look up to that. That'd be really great. If not, I've got a backup router that will help us hook up to the internet. So there you go. Make sure everyone's on the website. Has everyone found this one? goo.gl/V. goo.gl/V. All right, cool. So just want to make sure you get through that. Is everyone not there? Anyone not get to the Hackster page? This workshop's pretty fast and furious. It's going to be a pretty good overview of everything. I don't know what meetings you've attended before, where you've covered maybe some of these topics, but I'm going to go through everything. Like, we're new to IoT, and I know there's a few people that are new to IoT in this room, so I think it'll be a really awesome session for you guys. And we're going to try to get as hands-on as possible. So first part of this workshop will be actually to get the Blink running, because getting started with the board's always the trickiest part. I'm going to guide you through that really at the very beginning. Then we're going to go through all the IoT material, and then we'll do the cool IoT stuff, where we're going to use our LaunchPad plus Twitter using a service called Tembu, which is really great. Cool. All right, last call for this website. goo.gl, capital V, BYMUW. All right. So we'll get started. Today we're doing IoT specifically on Wi-Fi, but obviously there's a lot of other radios that we'll talk about as well. Today's Tuesday. Are you guys ready for the greatest crash course you've taken this week in IoT? Yeah? All right, let's do it. This is going to be good. So this is our workshop materials. I already handed out this to you guys. If you want an extra set, there's 2 more over here. You can just grab if you want. But we're using the MSP432 LaunchPad. This is a ARM Cortex-M4 processor. We've got the Wi-Fi, the CC3100 Wi-Fi module, and then we've got the educational booster pack, which is a nice I/O board. Has a really nice color LCD screen, joystick, push buttons, all kinds of great I/O that we can play with. This is your main processor board, your main microcontroller, the MSP432. This is an ARM chip. A lot of projects are using ARM these days. It's really the good way to start learning embedded design. This is a really nice general purpose microcontroller, 48 megahertz. You got a 14-bit really nice ADC on there, a whole bunch of different IOs, both on the booster pack header and then also on the bottom pinned out there, 100 pins total. And decent flash memory, and you even have this energy trace and debugger on the top, so you can actually track some of your current consumption of the entire system through Code Composer Studio, which is our main IDE. Pretty cool feature. MSP432 is part of our now SimpleLink MCU platform. So you may be familiar with some of our different types of microcontrollers, the MSP430, the TIVA-C, the CC3200 Dan mentioned. There's a whole bunch of different microcontrollers that TI makes. We have now a kind of family of microcontrollers. MSP432 is one of those. that has a standardized way of scaling your software and hardware solutions, standardized LaunchPad kits, SDK, software experience that you get to port between different processors. So let's say you start on the MSP432 today, you want to go to CC3220 or one of our other Wi-Fi MCUs. You can very easily take that same code, port it over. Really provides kind of an experience where you buy a processor from TI and then you can move to another processor very easily. It feels like it's the same company. That's kind of a thing that a lot of vendors have trouble with. TI, we're trying to fix that, make that experience really awesome for you as you upgrade your products over time. Like I said, lots of different microcontroller choices, development kits. We have training now called SimpleLink Academy, which takes you through really everything. You can go through real-time operating systems. You can go through how to use Code Composer, how to use different types of peripherals on your microcontroller, things like that. Really robust training sessions. We have the Resource Explorer, which we'll cover, the different IDE options, and the different code examples that you have there. This is your software story as well. You've got a lot of IDE options directly from TI. You also have some third-party stuff like Kyle, GCC, things like that. Today we're also going to be using the Energia IDE, which is Arduino-style option that you have. All right, so here's the pre-work. We're going to get the Energia IDE, so make sure you're downloading that while I'm talking in this first section here. Energia.nu is where you can get it. Go to the download link and get the Windows or Mac or Linux version. Then the other two things you'll need is a my.ti.com account, because we're going to be using the cloud browser in the first section as well. And then this tembu.com account. Tembu is going to be the API aggregator that we use in the end of the lab to do the Twitter stuff, and it's really cool. So make sure you go into energia.nu, download the one for your operating system, go ahead and grab a my.ti.com account and a tembu.com account. And this is all documented on the Hackster page, goo.gl/V-BYMU-W. Okay. So we're going to go right into lab one. Like I said, the hardest part is getting your board up and running. Want to make sure your drivers are all set up. Want to make sure everything is going good. So we'll do lab one at first. Then we'll cover all the IoT material. Then we'll actually do some IoT. So lab one, you will go to your Hackster page. So you should be at this page, right? Wi-Fi IoT workshop. That's the goo.gl link. Scroll down, here's your BOM list. Great thing about Hackster, it tells you everything you need to know for any specific project. So we've got our BOM of tools that we're using here. We've got our software tools that we're using, gives you some background, the pre-work, which we just covered, the energia.com/nu download, tembu, my.ti.com account. So now we're at lab one. Lab one, we're going to be using just our MSP432 LaunchPad by itself, just doing the out-of-box experience with our Code Composer Studio Cloud, which is your web browser-based IDE. For CCS Cloud, we recommend using the Chrome browser. I think it works on Firefox, but maybe not 100%, and then Safari and IE are your SOL. So definitely try to use Chrome if possible. And we're just going to go through this lab. It's all completely documented here, so if you get lost, if for some reason I'm going too fast, you can just refer back to the page. Step one, we're going to dev.ti.com. So dev.ti.com, this is your online cloud tools, resources, a lot of stuff, great stuff from TI here. We're going to be using that CCS Cloud link, so go ahead and click on that, CCS Cloud. And then this is where your my.ti.com account will come into play. So go ahead and log in if you have one, or go ahead and register if you did not register yet. So CCS Cloud is your cloud-based IDE. You may have seen these from maybe some other companies, but basically it gives you the option to very quickly do some development without having to install a bunch of crazy stuff. If you're familiar with like Code Composer, for example, that's a pretty beefy Eclipse-based IDE. 1 gig download, kind of long process to kind of get that all set up like you want it. With a cloud-based IDE, you just kind of log in, load it. The server compiles everything. It's really, really nice and flexible. The downside, though, is all your code is going to be on the TI cloud. So obviously for your products, maybe that might not be ideal. So you want to pull that into the local IDE later. But it's a great for getting started and showing some stuff that you like. So here it is. It's loading up. It's an IDE. You got your coding window. You've got your file project paths here. You've got some different options for your coding experience. Now we're going to go back to the Hackster page. We are going to, we've just did step 2. Now we're on step 3, which is the IDE. And step 4 is we're going back to dev.ti.com and selecting the Resource Explorer. So go back to your dev.ti.com here. There's a Resource Explorer, should be the first icon there. Go ahead and click on that. TI Resource Explorer has all your technical collateral for every processor that TI makes. So you go on TI.com, great website, awesome. Data sheets, app notes, product information, pricing. A lot of junk on there too, a lot of marketing stuff. As a developer, you kind of want to get to the crux of where are the code examples, where's the drivers, where's the schematics, things like that. That's where Resource Explorer is. It pares it down to all the technical kind of specific information. So everyone's on Resource Explorer hopefully by now. Go ahead and click that top search bar. Start typing MSP-EXP 432. So this is the part number of our microcontroller board that we have, right? So MSP 432 P401R, that's the LaunchPad that matches ours. Let's go ahead and grab that. Okay, and then, so now it's kind of filtered down to the specific board that we're on. We're going to go into the software. You see the software folder on the left-hand side. There is a SimpleLink MSP 432 SDK below that. You're going to go ahead and grab that one. You'll also notice on the left side below there, there's a couple more options. You've got the SDK plugins, which is nice. That's got your connectivity libraries like your Wi-Fi, Bluetooth plugin, more plugins to come. There's sensor and actuator plugins. And then you've also got some RTOS options as well. But we're going to go to the SDK, SimpleLink MSP 432 SDK. Go to the examples folder, and then go down. There's the demos folder. There's an out-of-box folder. And it does get pretty deep here, so bear with me. You've got your different options of using no RTOS, just purely embedded C code. You've got the option to use free RTOS or TI RTOS. And I'll explain later on why real-time operating systems are really awesome for IoT, because you don't want to be managing all those stacks by yourself, especially if we have multiple radios going on. But we'll talk about that in a second. Go ahead and select no RTOS. And then you've got your choice of compiler as well. You can do the GCC compiler, or you can use the TI kind of more optimized compiler. Either one of those works. I'll do CCS though. Out-of-box experience. Go ahead and click that one. All right, here's your main project folder. This will give you the actual C file, and then your different CodeComposer Studio stuff. If you want to look at that, it's fine. But on this view, there is an import to CCS Cloud icon. Go ahead and click that. And that will import into your CCS Cloud that we opened before. So I have a lot of projects, but obviously you guys probably may not have as many as me. But there should be one now called MSP 432 out of box on your left-hand side. Make sure that's selected. And then this is your CCS project. So you've got whatever C files, header files, includes, config files, whatever you got in there. This is a pretty typical CCS project. We're just going to go ahead and run it. And make sure you've got your LaunchPad connected in. So you've got your, where did I put mine? Got your MSP 432 LaunchPad out of the wrapper. You got your USB cable included inside of there. And then you're plugged into your PC. So go ahead and do that. And then you're going to click that green run button. Okay, just go back to the Hackster real quick just to show you where we are in the tutorial. So we did step 5, we did step 6, which was just double check our package picker. I'll just go through that super quick. Your package picker is this little icon here in Resource Explorer. Just make sure those are all the latest and greatest. If for some reason you're using a particular SDK version or something like that, you can manually select that from the Resource Explorer. So you can have stable code or whatever you'd like. The Hackster also, so step 7 we completed, which was open the example, we imported in the cloud, and then we connected our LaunchPad to the PC, which is step 9. All right, so step 10, we're clicking the run button, so go ahead and click the run button. You should get some pop-up that looks like this. Install the browser extension and download the Cloud Agent. The Chrome browser extension is what you need to get the compile going. And then the Cloud Agent will help you do the actual serial functionality from the LaunchPad to the PC. So go ahead and install your extension and your cloud agent. And click refresh.
Keep on getting, I got past that, but
Yeah.
after I downloaded it and installed it, it keeps coming up and saying it
It keeps coming up. Okay.
Yeah.
Are you using Chrome?
can't. Try to involve Chrome and Safari.
Okay. Safari definitely won't work. Chrome, yeah. We'll take a look at that in a second.
I first did it in Chrome.
Okay.
Install that.
Right. Okay. Yeah. Let me take a look at that in a second here. Everyone else, make sure you're following that procedure. And then on step 12, it should basically go through a load screen, make sure you install it. Step 13, it'll load for the first time. Well,
aren't working the way his screen is, so whenever I get an anomaly, if you keep moving forward, of course. So I think you're interrupting his talk.
so yeah, so make sure you're getting this first time load screen, and then it should finally load the code. And what you'll probably get is this error here. It says failure to connect to target. I need to run this update. Make sure you run that update. Then when you finally click run for the last time, it should upload, should say successfully flashed to memory in your debug console on the bottom. And then you should have a blinking red light, which you can then change with your push buttons. All right, so I'm going to take a quick 5 minutes and go around the room and make sure, see how everyone's doing.
You shouldn't need Chrome to validate the account, right?
You should not need Chrome to validate the account.
I just keep going back to the registration page.
Okay. Did you get it?
I tried sending a second one too.
Try like a new window or like a private window. Yeah. Are you guys okay? Yes. Okay, update. So once that updates, click run one more time and hopefully it'll. On the Resource Explorer. Yeah, and then there's this little button here that says Package Picker. And it's already all the latest, but if you need a certain version, you can get it. No problem, no problem. How is everyone doing here?
I'm so stuck, but I haven't had it. I guess I need to go into Chrome, right?
Yeah, you probably need to go into Chrome. Is this Firefox or what is it?
I downloaded the extension and probably all these things.
Wait, is this, what is this? Is this Chrome? This is Edge, okay. Yeah, you need to just open it in Chrome.
So I tried to do this, but
Right. So go ahead and go to dev.ti.com in Chrome and repeat the whole process. We're trying to load the code and the drivers all together so we can talk to the LaunchPad and program it. We downloaded the code from the Resource Explorer. That's right. So they had the sample code, we imported it into our IDE, and now we're trying to flash it to the hardware. That's right. Yes. Yep, this looks good. Yep, that looks good. And then you can change the color with this one, and then you can change the frequency with this one. Yep, so you're good.
then I get into the cloud.
That's
Then I
right.
go back into the resource.
Resource Explorer, do the whole thing again. Or no, it's imported already, so you're good. And then click run here. Yep, plug it in, click run, and then install the stuff. Yeah.
And then keep on getting this and actually install it.
Yeah. Can you try like opening a new window? And maybe close the IDE on the Safari side too.
Yeah, that's amazing. But you have to get here early and get it ready. What time do you get here? You're always here.
Alright, try to run again.
I mean, I know it
it's there. I was looking at
Yeah.
I was looking to see if they
Uninstall.
had a lot. It said it had a lot.
How about let's uninstall it and then try to reinstall it?
So apparently you can't use either one.
Yeah, I'm not sure exactly what else we can try here. It's not super important because there's another way I'll show you.
Yeah.
The main thing this exercise was doing was getting the drivers. So
I have the app.
if you got this right, well, I'm going to the website.
Oh, all right.
I think Mac you don't need a driver, so you're probably okay. But let's just read the instructions real quick. I don't know how to work these. And you scroll down a little bit, and then there's the Mac OS instructions. And no drivers are needed. Okay, so I think you're okay. It's not a big deal, basically. If we can't get it working, it's not a big deal. Okay, how is everyone over here doing? Did you guys blink successfully? Sorry. Your hard drive's full. Okay, that'll take a second to fix. How's everyone doing on this side? Are you blinking? Is everyone doing okay here? Are you guys? How to modify? Yeah. We'll do some modification later. Don't worry too much about that. But okay, so the point of this is you should come to should say this message at the bottom. You successfully flashed. Oh, where's it showing? You successfully wrote to the main memory, right? You wrote to the flash memory. Then your red light should be blinking, and then you change your color with one of the side buttons here. There's two side buttons. You can change the color with one of those, and then you can change the frequency by clicking your other button, and now make it blink slower or faster. There's also a GUI that goes along with it if you'd like to check that out. But basically, this is the vendor preferred, the TI preferred way of delivery for software examples. So you'd go in CCS Cloud, you'd find your example code like we did, right? We found the out-of-box experience. There's a couple more you can get there. Load those in. Make sure you got the appropriate hardware, follow the instructions required for those. And then you just flash them in, and then you can use the examples as a starting point. So that's basically how we try to promote professional developers to begin their development path. I'm going to show you in this workshop the rapid prototyping way, which is the Arduino style, let's make some stuff, do cool stuff quickly, and don't care how it works type thing. We're going to do that. But this is kind of the more professional way you get started. Take the vendor code, load it up into your hardware, load it up into your development kit, and then from there use that as a starting point to customize to your particular project. Okay? So, who is not successful in getting this properly worked? Okay. Like I just told this gentleman, there's a way. This is not super critical. What this exercise helped us do was get the drivers for the LaunchPad, especially for the Windows people. But we can do that manually later too, so it's not a big deal. All right. So I'm going to move on to the IoT lecture, if that's cool with everyone. Is that cool with everyone? All right. Sweet. Let's get back to it. I had a remote somewhere. Now I don't know where it went. All right, so IoT, basically, this is all built on some of the innovation that's happened in electronics throughout the whole years, right? So we got to take a little bit of context on what's the kind of historical stuff that's been done, which is what makes IoT exciting. So a lot of it starts from the forefathers, right? Edison, Tesla, mainstreaming of electricity, do cool stuff, powered, applications.
You're not taking a position on that fight, you're just kind of putting them.
That's right. They're just like, they're there, whatever.
pass right.
That's right. We're gonna roll through. There's tubes, there's transistors, there's all this cool stuff. Long range radio communication. TI, we're particularly proud of the integrated circuit. Jack Kilby was a young TI engineer. He was so new he didn't have any vacation time, so he had to stay back, do some work over the holidays, and he ended up inventing one of the fundamental building blocks of modern electronics. Right. So a lot of cool innovations. We're all standing on the shoulders of giants to do.
Which one was that? I'm sorry, I didn't get which one. Did you build?
He integrated circuit. It was
I see.
Jack Kilby. Yep, that's right. But what's more important is kind of where we've been recently and how that's kind of showing why IoT is cool. So the first big one was PC age, right? We had the personal computer, which is basically a whole bunch of innovation, both on the hardware and software side, right? And a lot of maybe us, a lot of our parents, whatever, participated in this wave of innovation, a lot of different types of applications, mainstreaming of the computer for business, for all types of different applications. Next big one was the internet. We have all these computers. They all can now talk to each other. What can we build with that? Huge innovation again. Your Amazons, your Facebooks, your Googles. Again, hardware and software innovations. Then you had the mobile stuff, everything. Now we're coming to the IoT age, which is, again, huge wave of innovation, huge opportunity for us to participate, building cool stuff for a whole bunch of different types of applications. I don't know if we're going to call it IoT in a couple years, but that's what we're calling it now. And it's basically the same thing: PC age, internet age, and what we're doing now. With IoT, you have the opportunity to make an impact on a whole bunch of different industries. So yes, there's going to be some people that build Amazon Echo. There's going to be some people that build Apple Watch, of course, right? But there's going to be some people that build some really cool medical devices. There's going to be some people that build some smart agriculture devices, energy sector devices, cool new plane, avionics, retail applications. You have the ability with your skill set as an IoT developer to impact a lot of different people in a lot of different ways. So a lot of great opportunity to disrupt. So a great time to be a IoT developer, and going to groups like the Charlotte IoT group. Great way to learn how to impact that for your passions. The IoT can be broken up into three major buckets. So you've got your edge. This is your computers, your mobile phones, your IoT devices, basically your end products, right? Anything that can talk to the internet is here. And we do a lot of stuff, both hardware and software, to support this. Then you've got your physical internet, your infrastructure, right? This is your Wi-Fi routers, your cell phone towers, your satellites. These are the things that carry the data throughout. And there's a whole bunch of companies and products related to the physical internet. Spectrum, Google Fiber, whatever. A bunch of hardware and software to do with those. Then you've got your cloud side. This is your major data farms, Google, Amazon, web services, IBM, et cetera. These are all your different cloud services. So lots of hardware and software at all three of these buckets, a lot of ways that you can impact the IoT through those. From an embedded perspective, there's a couple of places that we can play. These are more like the embedded electronics, your BeagleBones, your LaunchPads, things like that. You've got your wireless nodes, which are your end products again, your wearable devices, your smart home automation type products, your vehicle accessories, whatever it may be. It's something that talks to the internet, uses a radio and a processor to enable the application. Then you've got your gateways. IoT devices talk to the internet in a wide variety of ways. It could be Wi-Fi, it could be Bluetooth, it could be NFC, cellular. How do we get those all connected up together? So you look at things like Samsung SmartThings, Amazon Echo. There are certain products that act as gateways for these different types of devices. So you have the opportunity to build a gateway, connect up all these different disparate IoT products together to a unified experience. And then you've got your cloud services, and there's, of course, all the traditional ones related to the internet, but there's some that are specifically for IoT. IoT is a lot of data collection. You're collecting sensor data all the time. You're interacting with a lot of different APIs. You are doing all kinds of different things regarding for scale and big data. So IoT specific cloud services, and that's more of a software exercise, but definitely a huge impact to the whole equation. This block diagram is very standard for pretty much any IoT product that's built. You're going to have some kind of central processor, whether that's a more beefy kind of microprocessor or a more low power microcontroller. You're going to probably have some sensors on there. The best thing about embedded electronics is they can collect real-world data, so you can trigger things, based on the environment, different other types of sensing. You're going to have some kind of power. Is it wall-powered? Is it battery-powered? What kind of battery do I need? What kind of voltages do I need? You got to figure out all the power part of that. Motor control, more than likely. A lot of things, robotics, mechatronics, different types of intelligent movement type products. Need some kind of motor to enable that. Got some IOs, maybe some buttons, some screens, some whatever it may be, displays, and then you've got your RF communication, or your communication, which can be either RF or wired. So this is pretty much any product will have some kind of combination of those things. One question we get a lot is, what's the difference between a microcontroller and a microprocessor? Very, very common. Basically, what's the difference between an Arduino and a Raspberry Pi? What's the difference between a LaunchPad and a BeagleBone? They're both very good at what they do. You just got to know what they do, what they're good at. And then you can choose from there. It's just a design decision. First thing you should ask yourself, do I need an operating system? Microprocessor, the Raspberry Pi, the BeagleBone, they run a full Linux operating system, right? You can do Android, you can do Debian, you can do Ubuntu. If you need a full operating system, then obviously you got to go for microprocessor. For microcontroller, you're kind of limited more toward C-based control loops, low-level real-time operating systems. So it's more kind of a focus to the hardware there. So if you need an operating system, you definitely go with the single-board computer. Do I need it to be low cost? This is a little bit misleading because you go to the store, you go online, and you say, wait a minute, the price of a Raspberry Pi is just a couple bucks more than an Arduino. Obviously, I should go for the Raspberry Pi, right? That's true, but when you think about something, you're building an IoT product. I want to make 1,000 of these. I want to make 10,000 of these. I want to make 1 million of these. The cost of that microprocessor is significantly more than the cost of a microcontroller. So if you can design a product that can use a microcontroller, you're going to save a bunch of money on your BOM, and also a lot of complexity as well. Yes?
So just to get to the point, what is the price and volume for Bluetooth connection under TI? I was at a competitor vendor conference today, and I have a price in my head.
Yeah, I want to take that question offline. We'll do that at the end during the labs, because I got a lot of material to move through, and that's a little bit kind of a bigger question I got to get to. The last thing is, can I program with C or do I need to use another language? So a lot of us are like Python pros. We like Ruby. We like whatever we use, and that's great. But that's high-level languages. So you need a kind of more operating system-based type system to enable that. For a microcontroller, it's pretty much C land. You can do C assembly binary, and then there's some emerging stuff like MicroPython and some other things. Espruino, I think. But mostly it's C-based. So you got to be good at C. If you're not good at C, then you probably want to gravitate more toward the single-board computers. And the last thing is, do I need real-time capability? Microcontroller is really good for real-time, like I said, control loops, things like that. You can do stuff with that ability. With a microprocessor, there's the overhead of the operating system. They may not have the dedicated cores they need to enable real-time stuff well. So that can be a restriction for you. So basically, it's a trade-off, right? Microcontroller is a little bit more simpler to use, low cost, low complexity. You've got more control kind of over the hardware. With microprocessors, you got a huge significant bump in performance. So you can do more stuff like image processing or more intensive kind of processing. You've got the flexibility of an operating system of the languages. And then you've got different peripheral options as well. So that's basically a design trade-off. There's no right answer. Some applications it's great to use microprocessor, sometimes it's great to use microcontroller. How to pick a processor. Don't always trust the vendor to guide you. Number one, we have a lot of parts to sell. So I would be happy to sell you this MSP432. I'd be happy to sell you the AM3358, which is on the BeagleBone. All those great to me. So on the website, when you go browse vendors, they would be happy to sell you this for this application, blah, blah, blah. They just want to make sales. So you got to use, as your customer, be smart. Figure out what I need to do to address my application, what specs are required to build that correctly. Look for a good community as well. A lot of these dev kits, these popular processors have a community. There's forums, support, there's educational materials, training, there's people doing all kinds of cool stuff. Look for those types of things where there's a lot of activity, and that will help you kind of during the development process. Also be careful of well-written documentation. TI happy to say we're pretty well known for a good data sheet, app note stuff. A lot of other good vendors as well doing good documentation, but make sure you can read the documentation, understand it, and implement it. And also clean getting started experiences. Like I said, there's a ton of people that may pick up on our evaluation kit. They can't blink the LED, and then they're like, well, this sucks, and then they move on to the next processor. So make sure that experience is very clean. Look for good company support, distributor support. If you call up DigiKey, can they help you with a question from TI or whatever other processor it is? Pre-certifications as well. So if it's Bluetooth enabled, do they have some pre-certified type stuff to help me speed up that time to market? Be careful of NDAs, complicated licenses, poor distribution, and high obsolete rates. Those seem like a problem when you're developing a product, but once you actually launch the product and then they obsolete your parts or they sue you for bad license usage or something like that, that's going to be a bad experience. So be careful of that as well. Yep.
A quick question on the sensor tag, which is very cool technology. I don't know if it's 5 years ago or not, but I've got several of them. I got stuck on two things with that at the time. One, I couldn't get the over-the-air update to work, and the other was there really wasn't a development IDE that was available to push new code to it. So basically it became a doorstop. I mean, it was a really pretty doorstop, don't get me wrong.
That's right.
Beautiful case.
Was that the first one or the second one?
It was red and rubbery. I don't know.
They're both red and rubbery. One's the 2541 and one's the 2650.
It was probably the first one, to be
Okay.
honest.
Yeah, the first one was so the 2541 was an Intel 8051 core. So the push code of that is a bear, just regardless. The new one is an ARM Cortex M3. You can push code to it, but how TI treats the sensor tags is they're more demos. There's just basically a low power reference design showcasing how you use a coin cell with some sensors and build these either beacons or lightweight sensor type applications. But for real development, we actually promote the LaunchPad as kind of the primary development tool. It's got the onboard hardware debugger, and you can do a lot more stuff that you're traditionally used to.
You push code to the new one, you say?
You can push code in the new one, yeah. We have a special dev pack debugger, so you plug that onto it, and you can push code to it, yep.
And is there an IDE that's available?
That's right, you use the same one, so it's the Code Composer Studio or the CCS Cloud. Or
Things to watch out for?
things to watch out for?
Things to watch out for, required IDEs that cost $5,000.
Oh yeah, all ours are free, so I'll talk about that in a moment as well. Watch out for those expensive IDEs. I agree, they're a bear. All right, you've got a lot of different options for wireless. So they all have trade-offs, basically. There's no right answer. You got to look at what the spec is, see what's the range, how much data can I push through, what's the cost, not just the cost of the module, but maybe the cost of implementation. The power usage, also a huge one. Is your device going to work for a day, or is your device going to work for 9 years? And then also the adoption, how common is it in the marketplace? So Wi-Fi, ubiquitous, right? It's everywhere. We use it in our house, we use it in business. Even our grandmas know how to use Wi-Fi. They've heard of it. That makes it really, really nice. It's high bandwidth. The only downside with Wi-Fi sometimes is the power usage. So if you're doing an embedded device, you've got a small battery, you might have to charge that up a little bit more often than maybe a Bluetooth device or some other type of radio. Bluetooth, very common. It's on all our phones. Really nice to kind of hook up smaller embedded devices. The downside is it's a little bit smaller range. It's about 30 to 50 feet is what you normally get with Bluetooth. They're trying to change that with Bluetooth 5. We'll see how it goes. But regarding like 3, 4 Bluetooth, it's somewhat limited range. It's low power though, and it's also low cost. So it's a nice happy medium. That's why it's so common. You've got NFC RFID capability. So this is super near range, smart mobile payments, key card access type stuff. It's low bandwidth, so you're not passing a ton of data through that, but it's also very low power, low cost. You've got low power wireless area networks. These are Sigfox, this is LoRa, this is iGenu. Basically, they work like cell phone companies. So they're building up these towers. You can pay to be on these networks with your embedded device. And then basically in smart city applications where there's a big density of people or devices, these are really great. You can do some different types of sensor data type applications. It's wide range, so you can get like a mile or so from the tower type stuff. But it's a low bandwidth and it's a little bit higher cost because it's a developing technology. People are actually building out these infrastructures. Yep.
Is the NFC RFID the one to use when you're like
you're talking about like maybe the factory floor and you kind of want to triangulate the user's position at their mobile device?
No, that's not the right one. So the question was NFC the right one to kind of triangulate location in a building? No, it's very near field, like a couple centimeters or less. Bluetooth is typically used for that, and then you can also use Wi-Fi to kind of do that basic stuff, and also cellular, which I talked about later. So LTE, this is the big one. We all have it right. Really great for coverage. So they say we're at 98% of America, covered by LTE or whatever. Really awesome if you're doing things that are remote, like smart agriculture device or something like that, something, water-based, aquamarine-based type applications. You can get some cell phone signal out there. Problem is the expense, though. So you've got the module itself, which is way more expensive than a Wi-Fi or Bluetooth chip. You've got to have a SIM card, and then you've got your data plan, which guess what? It's AT&T, it's T-Mobile, it's Verizon, and they're going to charge you like it's a cell phone. They're trying to adjust that. They're going to have some more IoT-based plans. They have a whole IoT-based network called Cat-M, IoT, MB IoT. So they're working on fixing that, but at the moment, if you're building a product, basically you're building a cell phone thing. Sometimes it's worth doing that, but for a lot of applications right now, it's still very expensive. Then you've got Thread and 6LoWPAN. This is awesome. So this is basically kind of like Zigbee. These are related, but it's mesh networking technology. So instead of a star network like Wi-Fi, right, you've got a main router and then talks to the different nodes through that central thing. You've got a mesh topology. So node A can talk to node B. Can you pass the message to node C, and so on. So this gives you a lot more kind of network infrastructure scale. What's nice about Thread particularly is each of your IoT devices will now have an IPv6 address. So as a web developer or somebody that's building a cloud connection to your IoT device, they have an IP address that they can now interface with. With Zigbee, they didn't have that. Zigbee you saw more in kind of like smart grid type applications. So the power company, for example, would drive by your house. There's a Zigbee thing with your power meter, and they could read the thing without actually like going into your house and looking at the power meter. That's typically where Zigbee has thrived. But with Thread, like I said, you'll have an IP address, so you can do that. Google is heavily invested in Thread, so we're hoping to see some interesting applications with this in the next couple of years. So stay tuned. You've got infrared, which is your TV remote, right? Typical applications, the line of sight, low power, low cost. You've got satellite as well. So we have one group, the research group, building a robot for Antarctica. They decided to go for satellite. They're actually using the same chipset they're using, the MSP432. So satellite might be a good option for somewhere where at least you have access to the sky, right? So you can then pass data. Downside is super expensive, as you'd imagine. And then proprietary networks, this is more, basically you've got licensed, unlicensed spectrum that you can develop on. There's a lot more kind of thought than you put into that. These are different cloud services that you can utilize. Lots of different options. Some of the usual suspects. You've got IBM, you've got AWS, you've got some of the telcos like Verizon, AT&T, etc. Then you've got some emerging ones. One that we're going to use today is the Tembu. There's also a cool one called Blink, B-L-Y-N-K. It's pretty awesome. So there's a lot of cool little startups trying to do some IoT stuff. Basically either make the development of IoT easier, make the data storage or big data type stuff easier. A lot of different stuff they're trying to address. Power. How am I going to power my device? You got a lot of different options for battery. Battery is kind of the typical one. Is it going to be disposable? Is it going to be rechargeable? Depending on the battery chemistry, it might be thinner. It might affect the form factor of your device, right? So you got to keep in mind, am I trying to build a super thin device? Am I okay? It's like a, typical enclosure size device. Those types of things will affect your design decisions. Do I need continuous power? Maybe it's wall powered like the Amazon Echo, right? It needs to be hooked up all the time, so people don't have to change the batteries all the time. Is my application convenient to recharge? Is it okay to expect the customer to plug in their wearable every night? Is that a reasonable expectation? How mobile is the application? Is this something that's going to be carried around in my pocket? Is it self-propelled? Things like that. Form factor we talked about, and then the aesthetics. How do I make my product look good while still having the power I need?
Before you leave that slide,
Yeah.
can you talk a little bit about the resources you bring to these problems?
Yeah, so TI Webbench is the main one that we bring in, and this is basically how you design the power supply in the first place. It doesn't give you so much a way to select the battery chemistry or anything like that. You got to do your own research on that. But what TI Webbench does is basically I have, a design that needs, X volt, and then I need, this current range, blah, blah, blah. You plug that into Webbench, and then it'll give you the BOM for the power design that you need.
Some pretty good energy harvesting.
Yeah, we've got some energy harvesting as well. Yep. Yeah, that's all through our battery management group.
If you've got any dev kit with a low energy solar example, we should talk about.
Oh yeah, there's probably some reference designs that we'll have. Again, good question to take offline. Motors, which motor am I picking? A lot of IoT is going to be around intelligent movement. So you're going to figure out, okay, I need to move or actuate something. What kind of motor do I pick? You've got a choice between brushless, brush, stepper. Is it going to be AC powered? Is it DC powered? What's the accuracy of my movement? Is it a very precise robot? I might gravitate towards steppers, or I might use an encoder or Hall effect sensor. Do I need a high torque? Is this something that I got to go super fast, super strong? Complexity of the control. So am I prepared to write a big control loop algorithm with a more simpler kind of interface, or am I ready to do a less complex one? High efficiency and long life, because these motors do wear out. So picking out the right motor picking out certain motors might give you longer life than others, and then also the cost equation of that. So a lot of IoT will probably have to utilize motors. Then how do I display information to the user? You've got a lot of choices here as well. You've got LCDs, OLEDs, LED matrices, e-paper. You can even use cloud GUIs, right? Or mobile apps. These are new ways to display stuff from our embedded devices. Do I need color graphics? Do I require high refresh? Am I playing video? Am I displaying digits or alphanumeric stuff? And then what's the low power capability? For example, like e-paper is a great one. Very, very low power. A lot of people are using this for electronic shelf pricing in the supermarket, for example. You have dynamic pricing. The price of milk goes down 10 cents, so you got to quickly change that. So they build an IoT device using e-paper. E-paper, you refresh the screen once, and then it stays that way. So basically, the device goes to sleep, and then whenever you need to update, does the quick update, does it, and then sleeps. So things like that, right? How do I take advantage of my display technology to create an application that might be interesting for IoT?
Does that work particularly well outdoors?
Some of them do. So like the Kindles, for example, is another e-paper application. It does pretty well, I think, the ones they use, yeah. Better than LCD, for sure. LCD or any of the backlit type display technologies are going to be harder outdoors, yeah. All right, so types of human-machine interaction. So your IoT device will be one of these two if it's interacting with humans. It's going to be actively controlled or it's going to be passively controlled. All right, with active control, you've got somebody physically doing something with the system, right? You're pushing a button, joystick, touchscreen, whatever that may be. I'm pushing, my buttons on my Xbox controller. I'm controlling my thermostat, whatever that is. The key thing with active is it has to be responsive. If I click A on my Xbox controller and my character doesn't jump on the screen, that's a bad user experience. If I push the clicker on my computer, push the button on my computer, better type the thing. So make sure that you have a responsive system. And a couple ways that we've invented to enable that is graphical indicators. So you can have a loading screen, for example, show the machine is doing something. You can use light, you can use sound, haptic feedback. These are different tricks that we can say, while the system needs time to process whatever it's doing, we can give the user some experience with that. The other one's passive, and this is really good for IoT and embedded in general. You're utilizing things that make the system kind of work on its own, work automatically or without interaction. So these are things like you walk up to a storefront, the door opens automatically because it's got a PIR sensor. You're sitting in the driveway, your garage door opens for you automatically. Basically, it's leveraging different types of sensors or external data to enable that. Key thing with automatic is to make sure it's got to work. So if I open up my Bluetooth smart door and the lock doesn't open when my phone is paired, that's a bad user experience. It's very hard to debug as well. So if you do a passively controlled device, make sure that you're taking into account those types of things. Also, because it's IoT, you have the ability to leverage IoT data or internet data. So for example, if my application needs to do something at sunset, I can query a web service, say, hey, what time's sunset today? Bring that back down and then do something on my system. So it's sensors that are on board the device, but also external data from the internet that we can utilize. Okay, rapid prototyping versus embedded design. So prototyping is basically we're taking all these pre-assembled boards, right? The TI LaunchPads, we have this cool educational booster pack. We've got the Wi-Fi module. We're cobbling together some kind of interesting prototype application, making use of the open source software stuff, maybe the shields or the breakout modules from Adafruit and SparkFun, 3D printing, all this kind of cool stuff. That's prototyping. And we do that to prove our application, test different use cases, see what's the limits. Maybe we're showing this to people so we can get some funding, show it to my manager, show it to customers, whatever that may be. And basically we're developing this. We can make it really nice looking, but that doesn't mean it's ready for production. So embedded design is where that comes in. So just keep in mind, when you're building a prototype, you're prototyping, but then when you come to ready to release that product to market, you gotta move on to the embedded design phase, and that's basically optimizing for your cost, your scale, your manufacturability, your quality, right? If I release a product and everyone returns it because it's broken, this button is broken or whatever it may be, that's going to tank your profitability. So we're going to optimize our prototype for all these different factors and make sure it's ready for product release. Cool. All right, so your LaunchPad, basically rapid prototyping system, dev kit, very affordable, $10 to $30. It's got the onboard hardware debugger, access to the TI online resources. With big focus on prototype to production, so it's not so much kind of a maker tool as it is a professional tool that we give to the same engineers at Apple and all our big companies. Wide variety of performance options. We've got ARM-based chips. We've got low-power MSP430 chips, C2000 DSP-style chips, all kinds of different stuff, and then there's different software paths with those. This is your typical microcontroller development kit, very kind of common in the industry these days. The LaunchPad's about almost 6 years old now, so we're one of the first kind of developed these types of modular stuff. I think Arduino being the first one. But basically, you've got your main microcontroller inside. You've got your prototyping headers here. On the LaunchPad, you've got your hardware debugger, and then you usually have some kind of I/Os. So push button LED is the most common, but you might have like a display or you might have some sensors or something.
Atmel released a butterfly. That was a badge that had essentially all of these components on it.
Oh, okay. Yeah, perhaps. Someone must have been first. Inside a microcontroller, you've got your very classical architecture. So you've got your main CPU. You've got some kind of memory technology, whether that's a mix of flash and SRAM or the new FRAM type stuff. You've got some serial stuff, analog, either ADCs or DACs, your I2C, different type stuff like that. All these types of modular kits, they feature standardized pinouts. So this lets you build the shields, the booster packs, the capes, the hats, etc. All the pins are available on the same pin, so you can basically take this dead board as is, plug in whatever your custom circuit is on top of that, and use that as your prototyping platform. So that way you don't have to bother with putting the microcontroller on there. You can just use the dev kit and then add whatever circuitry you need. If you'd like to use, check out some of the TI ones, ti.com/build your own booster pack. We've got the Eagle and CAD templates, so you can start building your own circuits on top. These are some typical demo recipes that you can build with these rapid prototyping tools. So for example, if I've got an idea for a Wi-Fi kitchen appliance, very easily take a LaunchPad, take my Wi-Fi module, take a thermocouple, build that out. NFC RFID reader, for example, wanted to scan in people's work badges or student IDs, something like that. Very easily take, again, a LaunchPad, add the NFC component, add a battery to it, and start prototyping. And also sensor network, super popular, right? How do I get the temperature values or the humidity values in this room? How do I get the same values from all the rooms in this building? How do I aggregate all this kind of big data scenarios and see if I can make some changes that might have impact? Again, you can take rapid prototyping tools, build those out. There's also the BeagleBone line of single board computers. This one features the TI AM55X processor. Been around for a while, pretty large community, a lot of online resources, textbooks, different things from TI and beagleboard.org. Linux capability, again, like we explained before, you've got your choice of languages, your flavor of Linux, and it's also completely open source, so you're able to build your own derivative products. Take an example of Raspberry Pi, not quite as open source because Broadcom, they'll make you sign an NDA to get their chips. It's a big rigmarole. So you won't see a ton of like Raspberry Pi standalone products. You'll see a lot of things that hook into the Raspberry Pi and just use it as is. That's very common, but you won't see a lot of like Broadcom-based stuff. On the BeagleBone side, you will see people that actually make their own BeagleBone-based type thing. So something to consider. This is your peripheral set, so a lot of the typical stuff you'd see on a computer, right? USB, HDMI, Ethernet, a very decently beefy processor, memory capability. You even have a PRU, which is onboard microcontrollers. So the BeagleBone actually can do some real-time stuff on its own. And then you got your flavor of different things there. Again, standardized headers, so if you do want to build your own cape, you can plug that onto the BeagleBone. You've got 46 pins there for you to play with. This is the BeagleBone Blue. This actually came out this year. It's focused on robotics, particularly drone applications. So this would be kind of your main controller for some kind of custom drone that you build. It's got a lot of different connectors on here. You've got also different sensing capabilities, IMU. You've got onboard LiPo charger. You've got your Bluetooth wireless, Bluetooth Wi-Fi combo, motor drivers. So really, really nice, again, Linux controller for particularly drone applications, but a lot of different types of robotics. So if you need something that's low power, kind of stick toward the microcontrollers, the SimpleLink stuff, the MSP430. If you need something that's a bit more high performance, kind of go up the food chain to the Beagle. This is an example of an MSP430, one of our low power microcontrollers running off of 3 grapes. You see them there? So this just goes to show how low power some of these microcontrollers can be. This is running a very basic clock application. So yeah, something to consider as well. This is our product lines. Cool. So whether you're building one prototype or 1 million Apple Watches, basically everyone goes through the same kind of design path. You have a concept. Let's go quickly through the exercise. Say I'm Keurig. I want to invent a new coffee machine that has Wi-Fi, right? Seems like a pretty obvious one. So I have the concept. I do the research. How would I actually implement this? Start evaluating. Maybe I pick up a LaunchPad. Maybe pick up a particle thing, photon. See what works for me. Design it. Bring in my industrial designers. How's this machine going to actually look? Go through the prototyping. Fund it. Obviously, this is an internal project, so we'll make some budget to invest in it. If it's a startup company, go out and get some venture capital or some crowdfunding. Go into the marketing. How much is this machine going to cost? What's the right price to sell this thing at? And then who is the right customer as well, right? Who's the Keurig customer that actually wants a Wi-Fi coffee machine? We got to figure that out. Production, and this is the very important one. This is where a lot of people go wrong. You see a lot of Kickstarters. They have a beautiful prototype. They have a founder who's a rocket scientist from MIT, and they have this awesome 2-minute video that they take you through this whole journey of how they saved the world. And then they get to the production part, and you're like, okay, I backed this thing like 2 years ago. What happened, man? And they're like, well, we messed up and we couldn't produce it. So production's a huge, huge part of embedded and hardware in general, right? And the key philosophy that's going around right now is design for manufacturing. And that goes back to the embedded design part that I covered previously. So in prototyping, we go through the whole thing. We think we know how much it costs, blah, blah, blah. But in production, we got to optimize. We got to make sure we're picking the right thing that's low cost, effective, et cetera. With design for manufacturing, the philosophy is basically based on some things are easier to buy than others. So if you get a custom LCD, you might run out of that, right? The manufacturer can't make enough of them. Whatever, that could cause stock issues, and that creates a whole bunch of problems for your product. If you buy something that's more common, like there's a ton of components that go toward the cell phone industry, there's a ton of components that go into different common applications, you can buy those and they're a lot cheaper, first of all, and they're more plentiful, so you won't have any stock out issues and things like that. So design for manufacturing is basically looking at what's available in the market, what can I design into my product that will still be effective, but will save me a lot of trouble later on. Distribution, how am I going to get this around? Is it Walmart, is it Amazon, online? And then support, because you're going to be supporting any hardware that you release to market forever. So TI, we basically help customers with a whole bunch of different types of end equipments. We're kind of like Intel, but like less overt about our advertising. But we're in a whole bunch of different types of things. Basically covering the single chain. We're actually mostly analog. So we're doing digital stuff today, but a large majority of our business is actually analog. The amps, the sensors, digital converters, things like that. Normally I give this to the students, so this is our university website. And if you guys ever want to work for TI, ti.com/careers, welcome to check it out. Cool. All right, so I'm going to zoom through this so that we can get to the IoT stuff. This is our common denominator. We got a lot of different LaunchPads I talked about. Some with integrated Ethernet, some with displays, some with SD card readers, integrated wireless. They all have a wide variety of memory, processor type stuff, everything. So there's certain, depending on what you're building, you might need something that needs more digital signal processing, or you might need something with a dedicated LCD controller, or there's different things why you pick different processors. So we try to represent a lot of our portfolio there. This is one, just a quick shout out for FRAM. So I talked about Flash and SRAM. Flash and SRAM are the common things, right? One's non-volatile, the other's slow, blah, blah, blah. Basically, FRAM is the best of both worlds. So you can write super fast. It's low power. It's all non-volatile. It's a unified memory block, so you can write to any part of the memory. Basically, it's just an iteration of kind of the next best thing. So you see this in some of the TI portfolio. I'm sure probably similar type of memory advancements like this will be at other companies as well. But just something to keep aware that SRAM and Flash are popular today, but may not be the bee's knees in a couple years. These are our booster packs. Just zoom through these real quick. That's your educational booster pack, your Wi-Fi, different display technologies, IR stuff, NFC. Basically, there's a whole ecosystem of booster packs that you can access as well. These are some of our starter kits from Seed Studio. Seed Studio, a great company out of Shenzhen, China. They make this breadboarding kits for the LaunchPad, and also these Grove kits. These are really nice. Grove, the click boards from Microelectronica, and I think someone else makes one. But anyway, the idea of these, they're modular sensors. They're low-cost little things like a ultrasonic ranger or a little display or temperature sensor, whatever it may be, right? You have some different sensors that you need for your project. You can quickly hook these things up to your microcontroller and develop that. So they're really nice for prototyping IoT. This is the Click microcontroller. Sensor tags, we briefly mentioned that. Like I said, it's a good demo platform of low power sensor applications. It comes with some sample apps so you can get that data to your phone. Lots of different sensor technologies for TI. One exciting one I didn't add to this slide is we did millimeter wave, which is basically low cost radar for car applications primarily. That's one of our big customers is automotive and industrial. But we have millimeter wave sensing, so basically for anything that's like robotic cars or drones or anything like that, that would be a really good application for those types of things. This is our reference design library, so ti.com/TI designs. So for example, if you have any ideas for applications, let's say like a wireless charger, a Qi wireless charger, right? I want to make a soccer ball that I can like put on this little stand and charge up, and it keeps track of how many goals I make or whatever. I don't know how to design a wireless charger, so I go to ti.com, I can look up the reference design, pull that down with the full BOM and schematics and things like that. So this is really helpful. Definitely check ours out. Check out any other vendors for their reference designs because they might be able to save you a lot of trouble for certain types of applications. Okay, this is our software story. So we're going to be using the Energia next. This is the Arduino style, kind of rapid prototyping, super simple type stuff. Utilize the open source libraries, all that. We use the CCS Cloud, which is the web browser based one, and then there's all the professional tools from Composer Studio Desktop to IAR to Kyle, all the good stuff. With Energia or Arduino in general, I don't know if you guys are aware, but basically there's some abstraction going on. So with traditional microcontroller programming, it's all very low level, right? It's C-based. You basically break out the data sheet, the data book, learn the processor, see what each register does, kind of go through the whole thing. You got to be basically a 4-year, double E person. Very, very complicated. Then you actually write the code. It's all low-level C stuff. What some people have done to try to make that process a little bit easier is provide some driver library type app type stuff. So TI, we've done the same thing, or they might use a real-time operating system and make those calls to the low-level C code. What that does, that abstraction, basically helps you expand the code to more microcontrollers. So instead of just learning that one device, you can now port that over to some other devices, allows you to basically upgrade your hardware a little bit easier. What Arduino and Energia does is they take that up one more level. So now instead of all this APIs that we have to call in the driver library sector, we now have the APIs that are more human readable, a lot easier to call. So I want to read a sensor, so I call the analog read API for that pin. It's all very easy. So this allows people to learn electronics, embedded programming a lot easier, and it also allows them to port that same code into a lot of other types of microcontrollers. So we can use this code for Arduino, we can use this code for the LaunchPad, we can use it for particle photon or whatever, right? So that makes it really, really nice. The only downside to that is you don't have full control over what's happening down here at the low level. So you're not optimizing for power, or you're not optimizing for your particular peripherals in your application. So it's a great way to get started, get stuff working, but then if you really, again, want to do the embedded design, scale for optimal power consumption and other things, you really got to get a little bit lower. We can import our Arduino code into the professional IDEs, so you can actually plug in our Energia code into CCS Cloud or the CCS desktop. This allows you to take advantage of the professional tools like the Energy Trace, the hardware debugger. You can step through the code, see different things, check your registers, all that kind of good stuff. So that's really nice. Resource Explorer we covered. GUI Composer we'll cover in the lab. Okay, here's RTOS. So real-time operating systems, like I said, very important for IoT. Basically operates the same. It's a simple, like a GUI-less operating system is the idea. Very lightweight, but it handles the same thing like an operating system. You have tasks, so you can assign a task to your sensor reading, assign a task to your Wi-Fi call. Basically, you can segment out your program a lot easier, and then the operating system helps you manage those things. So instead of you having your main control loop and going through each thing, going through all these functions and interrupts, your real-time operating system helps you handle some of that load for you. The nice thing about the real-time operating system is it also helps you scale that code to other microcontrollers. So let's say we start our product with this particular Wi-Fi chip, but then the company releases a brand new one 2 years from now, and we want to upgrade that code. Having the real-time operating system allows us to do that very simply. And also it helps you account for the low power stuff. So while everything's in idle mode, the real-time operating system's making sure all your peripherals are turned off, different things like that. So that will really help you save the battery power instead of kind of doing that all yourself in C. So, yep, real-time operating system, highly recommended for any kind of radio-based coding. So a lot of options for you, a lot of IDE choices. These are different community-based stuff. So this is E2E, which is our main support forum. If you guys have any questions on any TI products, you can go to the e2e.ti.com forum, answered by all of our applications engineers 24/7. We've got this 4.3.0H community, which is more of our kind of hobbyist maker community. Pretty nice, a lot of enthusiasts for the MSP430 and different TI products. And then, of course, the Hackster page, really, really great. We've been working with them for a while, pretty close to when they started up. But there's a Launchpad page and then also a Texas Instruments page if you guys ever have any projects there. All right, let's go to the lab. Any questions here? Then we will go to the Hackster page and we will do lab
I got a question.
3. Yep.
Well, how come you needed to, since this is an Arduino-based IDE, Energia is, how come you needed to customize the Arduino IDE instead of just making plugins for it?
Yeah, well, we did it a while ago. So this was before they had plugins. So we launched ours probably 4 years ago, 3 or 4 years ago.
So wouldn't you want to go back and update your devices to make them plugins for the official Arduino IDE?
Yeah, so when we did, it's a double-edged sword. So when you start something in the beginning and then try to modify that back, it's a little bit harder because you've already invested a lot of effort already. So when we did that, we forked the original Arduino, like I said, a couple years ago. We basically customized it for the MSP430 at the time, and then all our TI products from there. And then kind of did our own fork of the development, basically, right? So we're running separate branches from Arduino. And we're able to pull in a lot of their features, which is great, and we love the community there, but it's a little bit harder to kind of merge back in. And also, it doesn't benefit TI because we kind of now have our own Arduino solution, and by going into the Arduino stuff, it dilutes us a little bit kind of in their community. Platform IO, I feel like they incorporated us at one point, yeah, but I'm not sure if that, did they get?
You see some of the boards.
Okay, yeah. Are they still in business or?
Well, it's open source.
Okay.
Adam is the IDE.
Okay, got it. Yeah, I know some, anyway, it's fine. Cool. All right, so we're gonna do lab 3 now. So we're gonna skip lab 2 and kind of get to the good stuff with the Tembu. So go back to your Hackster. Does anyone need the link to the Hackster again? Okay, so lab 3 on the Hackster. We're gonna plug in our LaunchPad. And go ahead and grab your educational booster pack. And then you're going to do it with the LaunchPad's USB cable at the top. You're going to go ahead and plug in so the joystick's on the left side, like that. And then for your Wi-Fi module, you can go ahead and just stick that on the back side. And then just make sure that your silk screen lines up. The silk screen is the text on the actual PCB board. So just make sure your Texas Instruments logo lines up with your LaunchPad logo. It should be in the right direction. Cool. So that's your stack. Yep. All right. So lab 3, we're going to use Tembu, which is a really awesome service. Hopefully you guys get to take advantage of this after the workshop as well. But you're going to go ahead and log into your Tembu account, or sign up for one if you did not log in yet. So Tembu is an API aggregator. So Tembu has over 200 or something APIs. They're all listed on the left-hand side once you log in. So things like Box and FedEx.com and Facebook and PayPal, Stripe, Twitter, USPS. So you've got a whole bunch of different APIs here that you probably would be interesting for your IoT device to hook up to. What Tembu does is they're acting as the middleman. So if you have any inkling of how APIs work, basically you can write a custom thing that your IoT device will connect directly to the API, but then let's say Twitter changes the API. So you have to, again, go back into your IoT device and fix that. But the problem is you deployed your IoT device. So now it's out in the world. Hopefully you have over-the-air update. But if not, then that might be a complicated thing. So what Tembu does is basically you interact with Tembu as the middleman. If there are any API changes, they'll help manage those for you. So you're always having the same kind of link to those APIs. So that makes it nice. All right, so everyone logs into their Tembu account, and then we'll proceed with the Hackster page. We're going to be using Twitter today. So go ahead and scroll down to your Twitter on the left-hand side. On the left-hand side, there's a Twitter. Go ahead and expand that. And then there's tweets. Okay. And then there's statuses updates. This is how I update my account tweet, right? So click that. So Twitter, tweets, statuses update. All right, so this is pretty much how Tembu helps us interact with the APIs. First thing you want to do is go ahead and select your platform. So you got a lot of options here. You got Arduino, you've got Samsung Arctic, you've got straight up Java, Node.js, Python. So you can use this with your single board computing like the Raspberry or the BeagleBone, or you can use it with the embedded devices like Arduino or TI. So go ahead and select your TI today. We're going to use the CC3100 booster pack, so make sure that's selected from the drop down. And then go ahead and create a new Wi-Fi connection. I should say add a new connection, booster pack. Call this whatever you like. Charlotte IoT or whatever. And then we're going to enter in, hopefully this works. If not, like I said, we'll have a backup plan. The Tsunami WPA. And the value added one.
From Timbo's Twitter, which is looking at getting access to your Twitter account to the TI stuff.
I would say that one more time. Sorry. How did I get to the Tembu stuff? Yeah, so we did, sorry. Twitter, tweet, status is update. That brought me to this screen. We selected the TI at the top. Got the CC3100 booster pack, and then we add a new Wi-Fi connection. And make sure the Wi-Fi connection is your Tsunami WPA value added 1. Okay. Cool. So now normally how API works, right, is we need some different arguments to help interact with the API. So if you go, for example, on Twitter, you go on the developer side of twitter.com, they'll give you some of this stuff, like the access token and the consumer key and all this. So whatever API you pick, they should have some kind of way, some kind of developer section or some kind of way to tell you how to interact with the APIs and give you some of these security type arguments that you need. So that's normally how you would get it. Now we've generated a Twitter account for you, so we don't have to do that today, but that's how you would do it if you need to. Also, you can test the code if you like. So basically we type in our API information before we even get to the LaunchPad. We can type a new status or something here, and then we generate the code, and then that will give us that will query Twitter through Tembu, so only the server side, server to server. And then give us the output back from Twitter. So that's just how you can test it directly without doing the hardware. Okay, so we scroll further down the page. You see here that Tembu has helped us generate some Energia code, which is awesome. So this is a quick test of the API, runs it 10 times, and then helps you do that update status. We're not going to use that today because we've got ours pre-generated, but we are going to use this header file. So if you scroll down a little bit further, there's this header file section. Go ahead and copy that. That should have your Tembu information. Okay. And then we're going to open up our Energia. So you should have got that big folder. Just go ahead and click the Energia icon inside of there. All right, we're going to set up Energia real quick. Sorry, this is actually lab 2, but we'll do it just hands-on here. You'll need a couple things. One is the MSP432 board file. So go to Tools, then Board. Then there's a Boards Manager. Tools, Board, Boards Manager. And then there's these MSP432 boards. There's two options, MSP432 red or MSP432. Just get the MSP432 no red. And then get the which version is it? 3 point something? You get the 3.8.0 version. And then click install. So Tools, Board, Boards Manager, and then MSP432 boards, get 3.8 and install. Okay. And then let's see. Okay, the other thing you can check is also your port. So with your LaunchPad plugged in, you should have 2 serial ports. For Mac people, you should have port 1 and port 4. Go ahead and select port 1. For Windows people, it changes based on your OS. So go to the device manager, and you can double check which one we need. So under ports, device manager, ports, And then there should be two XDS 110s, and then the one we want is the UART. They both program, so if you select either one, the program will still flash. But for the UART one, we actually get the serial back channel back. So go ahead and select the UART. For me, it's COM4, but it might be different for you. Okay, and then lastly, you're going to just quickly do another Blink example. So if you're familiar with Arduino, go to File, Examples, Basics Blink. And you can load this one with either the red LED or the green LED. If you want to do green LED, you can just uncomment your green LED line to the red LED and go ahead and upload that. So just like Arduino IDE, you've got this little kind of load bar here, and then you're going to have your output console here. It'll give you any warnings or errors, etc. And make sure you've selected the MSP432 board from the tools board selection after you downloaded it. Okay, so after that's successfully done, you should have your blinking board. Then we're ready to do a new program. So File, New. We're going to do a new tab. So I did File, New. I'm in a blank sketch. We're going to do a new tab by going on to the right arrow. And there's a new tab button. You can also do Control-Shift-N on Windows. Here's my blinky green LED. So new tab. That opens up that little text box on the bottom there. Go ahead and call this capital T, Tembu, capital A, account, .h. Tembu account, capital T, capital A, .h. From the file new tab. Or the new tab. Okay, that should open up a new tab as you'd expect. Now we've got a blank code. We're going to copy that header file from Tembu now. So go back to the Tembu website. There was this header file section. Go ahead and copy that. And paste that into our new tab. Okay? That's all you need to do. Now we're going to go back to the Hackster website. So now go back to the Hackster website. On the Hackster website, you're going to scroll all the way down to the very bottom. So we've done on lab 3, we've done steps 1, 2, 3, 4, 5. And then we're on step 7, which basically we're getting the code from the bottom of the Hackster, which is what it's telling us. So there, at the very bottom of the Hackster, there's a code section. And it's called tembutwitter.ino. And there's a copy button. Go ahead and grab that. Then we're going to go back to our new Energia sketch. We're going to go back to the original tab. We're going to blow this empty code out and paste in our tembutwitterdemo.ino. Okay, does that make sense so far? So we've got two tabs. We copied the header file from Tembu, and then on the main INO file, we copied the Hackster, the code at the bottom of the Hackster. Okay? So if your LED blink code worked, you should be good to go. Should be no errors. Go ahead and upload this. And you can call it tembutwitterdemo.com or tembutwitterdemo if you like. Compiling. All right, while I'm waiting, I'm going to take a workshop selfie with you guys. 3, 2, 1, smile. Nice.
Quick question about the IDE here.
Yep.
You've adopted a lot of the Arduino. Do some of these libraries for Arduino?
They will, yeah. So the key is, do they use the Arduino APIs or do they use the AppMel low-level code? So some people write libraries where they specifically use like the Uno code, low-level registers and things like that. It's timing-based. Those won't work because obviously it's different architecture.
You ported the Arduino IDE or the Arduino, what do you call it, API?
Yeah, that's right. So any of the, if they just call the regular Arduino function calls, then those will work. Yeah. So.
Can I look it up? Will this library work with?
No, we don't have a way to do that. You kind of have to self-explore. So if you see that, yeah, just try it out. So sometimes it'll compile straight out. Sometimes it won't, but maybe there's just like 1 or 2 functions that are weird, and you can comment those out, and it'll work. And then sometimes you'll look in the code, and you'll see that they're actually calling registers and doing low-level stuff, and then you'll know that definitely worked. Or you have to port it yourself. Okay, so mine uploaded. So let me take you through the demo now.
Right? Oh. That's my go-to.
Okay, so inside of Energia. Nope,
That's an example.
Oh, yeah.
Here we go. COM4. Okay. There is a reset button on the top of your launchpad. It's that top push button. I'm just pushing that. And then we're going to get our Wi-Fi code. Hopefully it connects up. This will be our first test. Oh, let's see. It's not liking that. All right, we'll have to go to the backup plan, which is here. Oh, it did go. Okay, took a little bit longer than usual. All right, so the out of box is basically you can select any of the buttons on your setup. So you got 2 side buttons on the launchpad plus the 2 push buttons plus your joystick button. So I'm going to go ahead and click one of those. We're making the query now to Tembu, which someone must make the query to Twitter, and then they're going to get the response back. So we did get that. You see here we got 200 code, which in HTTP land is good, and then this gave us our JSON response back from the server. Okay, so that all looks good. So we're going to go now to the last page, which is twitter.com/IoT dump. And then you see here, 29 seconds ago, I pushed back button 2. Okay? So that's it. So now go ahead and start pushing your buttons. And we should see some tweets. Libraries, the rapid prototyping dev kits, and the cloud services all together, figuring out which ones have a smooth development, like I said, very clean out-of-box experience. Then you can really fly super fast, right? So that's pretty cool. Is everyone impressed? Was that cool?
Yeah.
Okay.
Very helpful and very generic.
Yeah. So it's the same thing. I'll wait for you guys to start pushing buttons, but it's the same thing. Basically, Lab 5 is going through Yahoo Weather. But basically, Tembu works the exact same way that we just used it. So if we go to Yahoo, we go to Yahoo Weather, and then Get Weather, I think. Get Temperature. So same thing, right? We set up our booster pack, make sure our IoT our SSID is correct. Then we can grab the Charlotte temperature right now. It says 79 degrees. Does that sound right, maybe? And then again, grab our test code for Energia, grab our header file, and then we can start using Yahoo Weather, just like we did with Tempo, like super quick, right? Same thing with Facebook, same thing with eBay. You can explore all these APIs, see what you can do with it. I can find items by product on eBay. What can I do with Amazon? I can do EC2 management. I can allocate stuff on my EC2 automatically with my IoT device. I can do GitHub stuff. What can I do here? Gists. Gists are cool. Create a comment on my gist with GitHub. So there's all kinds of different stuff that we can get our device now to do. And it's all very uniform. It's all very easy to kind of test and use. And then you incorporate all the Arduino open source stuff and the, everything else, and then you can really get going quick. So that's the coolest stuff I can show you. And then we won't do the rest of the labs. Like I said, this was lab 5, was using Yahoo Weather. Lab 4 is showcasing the GUI composer that we have. So GUI development is another big kind of thing that you'll probably have to do for your product design. There's obviously custom. You can build a custom web app. You can build a custom iPhone app. You can build a custom Android app. Or you can utilize some of these like cloud services and tools to help you build the GUI. There's things like Freeboard.io. There's Blink, the BLYNK I talked about. And then TI, we have a GUI composer as well. So that's what Lab 4 does. It basically takes you through how you build a GUI through GUI composer. But that's it. That's it, guys. Was anyone able to successfully tweet? Let's see. I see one person. C-Stick got through. Cool. All right. I guess we'll do the drawing now for stuff. While people are still.
I think that first one you got through should be the first one.
Yeah, I should think so. So let's see. Yeah, should we do that? So I have the top 3, whoever's the top 3 of the tweets. Or should I do a random drawing? I know the guy that's like on step 5. It's just at the. All right, we'll do a random drawing then. Okay, so everyone's going to get a TI pen and
One of them right.
a sticky note, and you're going to write your name on it. And I will collect them in a moment. So everyone right there, so there's a sticky side on the sticky note, obviously. Write your name on the bottom of the sticky side, then you can fold it.
Should we tell them about the prizes?
Yeah, you can sure refresh.
Oh, refresh the screen, yep.
Tell them about the prizes.
In our theoretical.
Last time I tried it, the API didn't work.
We did
No,
it.
C6 still winning that one.
2 weeks ago.
Yeah, there you go. We get some custom stuff. So we'll talk about that.
I think it's in
Wait, sorry, we got-
Where's my laptop? On the floor?
That's probably not a hack with private drawing.
Alright.
Get your name on the sticky side.
Just kidding.
Come over to the other side.
I may as well pass out these stickers. Here's one of these stickers. We have now, then that's what's left. They said on Wednesday, that's underneath.
Yeah. You never have enough. I already got it for my kids too. Oh yeah. Did I go? Sticky. Covered up.
Yeah. Super lucky for you. That's right. Just put your name on the sticky side.
Doesn't take much to make me laugh.
Especially late at night.
Does everyone get their sticky note? Okay.
Dan, did you want to try one?
Oh yeah.
Thank you very much.
You are welcome. Alrighty. Now we'll collect. Let's check the Twitter feed.
Make sure your boxes are.
Oh, we got one more. Albert Zera. We're on there. Okay, just to show you guys again, so it's not black magic. So we're in the 10-bit Twitter demo.ino. If you guys wanted to modify your Twitter, here basically we're just polling. It's not interrupt driven, it's just polling for the button press. And then here under status update value is where you see the string that we have, right? So for account, Easley, current value is the booster pack button. So we're taking variables from the embedded code, we're putting that into the string and then sending that to Twitter. So if you want to customize your string that goes to Twitter, you can do that there. Okay, now we'll collect. I'm going to fold that in.
For that? Smells lucky. Good.
Sweet.
What happens is see everything else. Some just so. All right. You have your go to 10.
All right, cool.
But then once we get back, it's only the stuff. Certain pieces. Oh, that's good. No. The microphone died, so I'm just going to add all the way here. Where it will come a little bit.
Oh, yeah. Look, I'm trumpeting.
Such a short distance.
Maybe
What's the word for that? Commuted distance. So this is just short commuted distance. Shorter. Making sure it's not long. Those are all warnings that you can
David J. Not that I have any.
You don't want to write words. Find this in with BMT, doesn't have that extra stuff.
He's got lots of percent. And he'll have to take the
MSP
PlayStation
432.
and wait for Wii.
No. Not the board. You select just all things from the board. Just like you could go to tools. Put a voice manager.
I am putting people on Monday.
Now find. Try this one. This one. Let me make sure I'm
Make your Indian. You're blue gun. Depends on PlayStation Crew. It's actually well, they made a board. The pieces actually moved as it was wrong. And Jimmy shot like made puzzle thing.
Yeah, I put mine in the back of my card.
And board pieces and stuff. If they interest
Set
in
replacement, they could. You can get a lot more.
You get a lot more.
Yeah.
Yeah.
They hit it so many times. They're right.
Now from tools to the board.
I think yeah, I think they're.
You don't want you to give them a little bit.
Now you
I know, right?
Right now, I'm like, well, yeah, this is kind of hard to use it
You hit a lot.
Oh, the cloud? No, we recommend using it. So whatever you want to do.
I guess you can sign off the broadcast. Too bad for you. Everyone else got up.
Okay, cool, we'll do the drawing.
Where is that?
Reset is on the top. Let me just check your Wi-Fi. Yeah, we're just lining up their logos here. They can go both ways.
Yeah, I was behind.
Then we can.
Alright, now.
We might have to close this or something again.
So I had the other one selected, and it still works, so the one goes.
Okay, so now it should connect up. And then you hold down one of the buttons. All right. So the three prizes today, three main prizes, will be your MSP432 LaunchPad, and then you have a choice of doing the Wi-Fi, or I have 3 Bluetooth booster packs that you could use as well. So you tell me what you want to win. And then I've got some USB sticks, but I don't know if that's like, is that prize worthy?
Yes.
Yes? Okay, so we'll give out 10 USB sticks. Okay, cool.
What you do is you plug them into your coworker's laptop and then you're supposed to do that.
Yeah, that's right. Okay, cool. So here we go. We'll do the 3 LaunchPad sets. First winner is Thulasi.
Okay. Do you want Bluetooth or Wi-Fi?
Wi-Fi.
Okay. Next winner is Michael Sarian. Do you want Bluetooth or Wi-Fi?
Wi-Fi.
Okay. Easy. And our last winner, Kelly Hendricks. All right, do you want Bluetooth or Wi-Fi?
Bluetooth.
Oh, okay. All right, I'll give out the other 2 Bluetooth booster packs, but you only have the booster pack. You won't have the LaunchPad. Does that sound reasonable? I don't know. The LaunchPad's only $13 though, so it's, I don't know. Could be a good deal. All right, we'll do 2 more. So we'll have 5 total. Oh, this one is sticky. This one's Jay Armstrong. You get the Bluetooth booster pack. And then this is Leo. You get the Bluetooth booster pack. All right, cool. So now we'll do 10 USB sticks. Which should be pretty much everyone in this room, I think. So Jay Wagner, you get a USB stick. And NASA Ramana, you get a Bluetooth, you get a USB. Brachan Haridi. Am I saying that right? Brachan Haridi? Come see me after. RCB Schoon, or Rob Schoon? Rob Schoon? You get one? See me after. Joseph M, you get a USB stick. And Dan, you get a USB stick.
All right. Which Dan?
Dan Hugh. Dan Thayer.
Oh, sweet.
That was 6 people. Chuck C, you get a USB stick. Travis, you get a USB stick. And Patrick Graham, you get a USB stick. And one more. Chris Burgert. Close enough. Chris Burgert, you get a USB stick. All right, well, sorry for the rest of you guys, but you get a pen, so that's good. Cool. Thank you for having me, guys. This is awesome.
I want to thank Mark for a great presentation. Thank you for coming from Raleigh and showing us all the TI goodness. It's awesome. And also remind everyone, Monday, we're going to have another epic event. So tell all your friends. It's Microsoft IoT. We'll do some labs with IoT Hub and all the Microsoft IoT suite. So it'll be awesome.
Quick round of applause. This was a great workshop. Really, really well.
All right, sweet. Yeah, so everyone else, go ahead and pack up your hardware. And then the 2 folks that got the Wi-Fi pack, you just keep your Wi-Fi, but give me back the educational booster pack. And then the Bluetooth folks just come and see me at the front here. And then USB folks.
What is the Internet of
Thank
Things?
you, Dan.
Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.